Hello everyone, welcome to this presentation. The topic today is trapezoidal rule. The question requires us to complete the table below for the function y is equal to 3x squared minus 8x plus 10. We have the table right here, and hence estimate the area bounded by the curve and the lines y is equal to 0, x is equal to 0, and x is equal to 10. Using trapezoidal rule with 5 strips. So before we continue, I want us to have a picture of the area bounded by the curve and the 3 lines. So let's have a sketch. This is the y-axis, and here we have the x-axis. So suppose this is the curve. This is curve y is equal to 3x squared minus 8x plus 10. Now we're going to look for the area bounded by the curve. The line y is equal to 0, that is the x-axis. So this is the origin. And line x is equal to 0. Line x is equal to 0 that is the equation of the y-axis. So here, x is equal to 0. Before we get line x is equal to 10, we are going to partition this, the area under the curve, into different trapezia until we get to the line x is equal to 10. And in order to do that, we need to get the width of each trapezium. The width is usually obtained as, so you take these extreme values, the extreme values of x is equal to 10 and x is equal to 0. Get their difference, that is 10 minus 0, and then you divide by the number of strips. So here we are told there are 5 strips. So you divide by 5, and that gives us 2. This means that the width of each trapezium is 2. So we can begin our partition. So from x is equal to 0, after a width of 2, that is, we have x is equal to 2, x is equal to 4. Now we will stop when we get to x is equal to 10. Here x is equal to 6, x is equal to 8, and finally x is equal to 10. So we have widths of 2 all through, it's uniform. So we're looking for this area here, the one I'm shading. This last line here is line x is equal to 10. The first line here is x is equal to 0. Then we have the x-axis and the curve. That region there is the one we are estimating its area. We can now continue to the table. The table requires us to determine the values of y when the values of x are given. So just as we have them on the table, we can see they correspond to the values we've obtained here. So in some questions, you may not be given the table to fill, but you are to come up with it. So from the sketch, you can easily know the values of x and then determine the corresponding values of y. Here already we are given some values of y, so we are required to fill in the remaining parts. So doing our substitutions, we know that y is equal to 3x squared, so x is unknown, minus 8x plus 10. So doing our substitutions in the brackets in place of x, when x is 6, we are going to have y being 70, and when x is 10, we are going to have y being 230. That is upon substituting the values of x in this function here. Alright, so with the table already filled, we can now continue to the rule itself. Now the trapezoidal rule is given as area is equal to a half times the height, and the height we already have as 2, a half times the height into the sum of these two values, the values of y for the extreme values of x. So the value of y when x is 0 and the value of y when x is 10. So those are the ones we add in this first bracket. The value of y when x is 0 is 10, and the value of y when x is 10 is 230. So adding them, so we have 10 and 230. And then next will be twice the sum of these values here. The value of y when x is 2, value of y when x is 4, value of y when x is 6, value of y when x is 8. These values are the ones we add inside this bracket. So when x is 2, we have 6. When x is 4, we have 26. When x is 6, we have 70. And when x is 8, we have 138. Those are the values we are going to insert here. We have, when x is 2, we have 6. When x is 4, we have 26. When x is 6, we have 70. And when x is 8, we have 138. From here, so this and this cancel. The first bracket here is 240 plus this second part is 480. And then when you add, we get 720 square units. And thus we have estimated area bounded by the curve and the 3 lines as had been required. With that, we come to the end of the solution to this problem. I want to thank you for watching. I hope to see you in the next video. Bye.